Welcome back, pre-calculus students. We're going to look at a very special function and one of its properties. The function is 1 plus 1 over x to the x. And what we're going to examine is what happens when we take this and we have x approach infinity. In other words, we're going to keep plugging in bigger and bigger and bigger numbers. To help us with this, we've created a table where under my y values is the function itself, and now I'm going to enter table values and see what happens. Trying to divide by 0. Obviously it's not going to let us do that. So we're going to go to the next one. When enter 1, it's 2, 2 is 2.5, and as you look at these values, they're getting bigger and bigger and bigger, but they're approaching a number. And the larger the number we put in, the smaller the number goes up by. You know, putting 25 in 2.66, we can even get pretty big pretty fast. Put in 100, maybe 200, go 500, and we're starting to approach a graph. We're starting to approach a number. On a graph, this would look something like this, where our function would get closer and closer and level off. This value that we get closer and closer to level off has a very special name. This is called the natural number. And a lot of you may know this by the term E. E can be found in a calculator, which is pretty useful because we're going to use it a lot. By second division symbol, an E is going to be about 2.718. And E is going to creep up into a lot of our math, so you got to get comfortable using it. When you use the base of an exponential function, the function is just called a natural exponential function. And these work exactly the same, except for now our base is E. E is just another number. It's a constant. Kind of think of it like pi. Pi and E are similar because they're letters that represent very specific numbers. So to find f of 4 for e of x, for the natural exponential function, e to the x, it's going to be e to the fourth. We can use our calculator to help figure out what that would be. Second, e raised to the fourth power is going to be 54.59. Same thing. Now, what I've done here is looked at some basic rules to help us remember this. We won't necessarily evaluate these with our calculators. E to the first, remember any number to the first power is just itself, e. E to the 0, anything to the 0 power is going to be 1. And finally, when we take something like e to the 1/3, what that's asking us to do, because it's a fractional exponent, is take the cubed root of e. You can evaluate those in your calculator, but we don't need to. Graph the following function. E is going to be the same. This is going to be the same thing, except for our base is now e. Instead of going 2.7, most times you could go about 2.75, 2.5. For our second number. So again, our base, one of our critical numbers, 0, 1, we'll go up to about 2.75, kind of approximate it, and that should be okay. This is what our just plain old-fashioned e to the x would look like. But now we're going to perform our translations. We're going to go left 4, we're going to go down 2, left 4, 1, 2, 3, 4, down 2, 1, 2, left 4, 1, 2, 3, 4, down 2, 1, 2. Again, our asymptote comes with us, and our graph looks something like that. That's E, that's the natural number. It shows up in practical examples a whole bunch. Just want to make sure we are introduced, we are all on the same page.